So here's our first example in graphing a rational function, 2x minus 6 over x plus 3. Reminder that you're going to be wanting to look at this sheet over and over and over again regarding what to do for each step in the process. By the time you're done doing all this, you shouldn't have to look at all at this sheet and at this cheat sheet of what to do for what part of the function. So what I recommend before doing anything else is if I can factor this equation on top and bottom, I'm going to do so. It just makes it a little bit easier. So I have 2 times x minus 3 on top and x plus 3 on the bottom. That way I have a couple of different forms that I can look at in solving this problem and analyzing it. So first, domain is when the denominator equals 0. So I'm going to set denominator equal to 0, and I will get an answer of x equals negative 3. That's when you have domain issues, is when you have x equaling negative 3. That's what you can't have. So I want everything except that. So from negative infinity up until negative 3, and then from negative 3 up until infinity. So everything except for negative 3. X-intercept is when the entire function equals 0. Well, if the entire function equals 0, that means your numerator has to equal 0. So I'm going to set the numerator equal to 0. Well, 2 can never equal 0, so that doesn't help you. But x minus 3 can equal 0. That happens when x equals 3. So when x equals 3, and the y value is 0. So you have an ordered pair of 3, 0. Y-intercept is when you plug in 0. Try to change the colors up. Y-intercept is when you plug in 0 for everything. When you plug in 0, I should get negative 6 on top and 3 on the bottom, so I should get negative 2. So x equals 0, y equals negative 2. Next step I do is I look at vertical asymptote versus whole, because they both deal with the same thing, which deals with the domain, which is the denominator, domain denominator. So vertical asymptote and whole happen when the bottom equals 0. We said the only place that happened was x equals negative 3. Did that x plus 3 cancel with the numerator? If so, it would be a whole. But because it didn't, it's going to be a vertical asymptote instead. And you just write it as x equals negative 3. Nothing canceled in the function, so there is no whole. Horizontal and slant asymptote is the only thing that's left to do, and that's the tough part because we have to use long division. The way you set up long division, you set the top to go on the inside, the bottom to go on the outside. You technically can do synthetic division. It just ends up being a little bit easier and more consistent if we always do long division, because you can always do long division. Synthetic doesn't always work. So, as I'm solving this, I say x times what gives you 2x? The answer to that is 2. So I put 2 up top, multiply my way down. 2 times x gives you 2x, and 2 times 3 gives you 6. I need to subtract that entire thing. 2x minus 2x is nothing. Negative 6 minus 6 is negative 12. That's your remainder. So my new equation is this, 2 plus negative 12 over x plus 3. Horizontal and slant asymptote is this part that you get in front of the remainder. So your horizontal asymptote is y equals 2. It's horizontal because y equals 2 is a horizontal line, not a slanted line, so there is no slant asymptote. Again, if there had been an x here, for example, that would have been a slant asymptote. So you can only have one or the other. And the last step is cross. Where do you cross the horizontal asymptote? Well, that happens when the remainder equals 0. So when does negative 12 equal 0? It never does. So we don't have anything crossing a horizontal asymptote, and that's actually pretty common not to get something crossing the horizontal asymptote. So that's good. We've got all the information we need. Now we're going to use all of this info that we have to graph our function. So what I'm going to do first is I'm going to plot everything I know. I'm going to start with my x and y intercept. An x-intercept is at 3, 0, and a y-intercept is at 0, negative 2. We have asymptotes. A vertical asymptote happens at x equals negative 3. So I go to negative 3, and I'm going to draw a vertical line. And then I'm going to do the same for horizontal. The horizontal is at y equals 2. So I'm going to draw a horizontal line. No slant asymptote, no hole, no crossing of an asymptote. So I've basically plotted everything that I can plot. All I have to do now is connect the dots. Well, the only way I can connect these two dots and follow the asymptotes, that's the trick. You have to be able to follow along where the dotted lines are and not cross them, is something like that. Now, here's the issue. I have 2 parts of a domain. That means I need 2 parts of a graph. I only have the part here from -3 to infinity. I need something on this section of the graph as well. Well, we don't have any points, so that doesn't help us. Our only options are we're either going to be up top like this, following the asymptotes, or on the bottom like this, following the asymptotes. It can be one or the other. It can't be both, because then it wouldn't be a function anymore. The way that you tell which one it is, well, if I drew this bottom function, I'd have to cross the x-axis again. I'd have to have another x-intercept, which I don't. So that means that it can't be the bottom function. It has to just be the top function. And there is your graph. You have 2 parts for 2 sections of your domain. You've connected the dots, and you follow the asymptotes. That's the steps in the process that you take.